Okay, our topic tonight is portable fire extinguishers. So, who has had an opportunity to use a portable extinguisher in some fashion or another, like for a fire or just screwing around? Anybody?
Yes. Johnny says yes.
What kind of extinguisher was it?
Just household portable, expired. Might as well use it.
So an ABC dry chemical,
Yep.
probably. All right. Anybody else?
Yeah, I've used a few of them off of a couple trucks before.
Okay, cool.
It was not a good scene.
So what kind of scene was it?
It was the power room to a sawmill,
Okay.
and it was the transformers and stuff inside the room it caught on fire in between the transformer and the wall.
Yeah.
And there was enough juice in there when you went in, your hair would start tingling and standing up.
Oh, nice.
So, yeah, definitely no water whatsoever.
Right. So did you put a fire out or you didn't have a chance to?
Yeah, we got it out. We had to kill the power to the whole plant and kept it, knocked it down until we could tear the wall apart and get all. It was just a sawdust from the plant that was on fire inside the wall.
Yeah.
So there was no insulation in it. It was just dust everywhere.
Sure.
So we had to tear it apart to get it all out.
Yeah. Yeah, we'll get into some of that in fire behavior, obviously. The small particulates like sawdust and dust from grains, they're extremely flammable. And so you had a taste of that plus messing around with an extinguisher. Cool. All right. Well, as I said, we have portable extinguishers. And we're going to go through the IFSTA PowerPoint. It should take about an hour, 70 minutes or something of that sort. And we'll be able to get through it fairly quickly, I think. So can everybody see the PowerPoint presentation?
Yes, sir.
And do you have the GoToMeeting on the left-hand side also?
Looks like we just got the full screen presentation.
Okay, good. So this picture that's up, this is Ward Watson. He's our maintenance coordinator technician. And a few months ago, we had an opportunity. He's been the one that's been teaching extinguishers to the department, or refreshing extinguishers to the department. And we had a bunch of extinguishers that were expired. So he taught a few classes, kind of an upgrade on a lot of details on all about portable fire extinguishers. So this is his grandson, who had an opportunity to mess around when we were taking a break. You can see, as long as you know how to use an extinguisher, you can be 6 or 8 years old, all the way up to however old Ward is. Okay. So portable fire extinguishers have a number of different classifications. And does anybody know what the different classifications are used for offhand?
The type of fire that you're extinguishing?
Yeah, exactly. Very good. So what we're going to be doing is going through the 5 different types of fire extinguishers that are typically used. They're based on the choice of extinguisher is based on the type of fuel that's burning. So Class A fuels, which are our common ordinary combustibles, includes the list of things here. This is the typical inside the house type of fuel load, fuel mixture. And like you said, it includes wood, textiles, plastics. So this includes most of the typical building constructions, furniture, cabinets inside the house, cabinets around your kitchen stove, all those types of things. Most things that are in a typical office as well. For a Class A fire extinguisher, what's another name for that? All right. Well, one of the fire extinguishers that we use quite a lot, and we have one on all of our frontline larger apparatus, is a water extinguisher, sometimes called a can or a water can. These are the silver stainless steel or aluminum extinguishers. Another type is a water-based agent, which has a Class A foam, and then the dry chemical type of extinguisher, which is just that. It's a powder chemical, similar to what Johnny mentioned he used when he was messing around with his extinguisher. And was it John Roybal? That was probably the type of extinguisher that was used in the plant where they had to rip into the wall. So Class B fires include flammable and combustible liquids and gases, alcohol, gasoline, diesel fuel, oils that you'll typically see in most motor vehicles, liquid propane, as well as natural gas. Natural gas and liquid propane are close but not quite the same. And these are all types of things that we will typically go on a call for a fire situation as well. Obviously, a motor vehicle fire, you have gasoline. Some homes, a lot of homes have liquid propane up here, especially in Gilpin County and our surrounding neighboring districts. Most people will have liquid propane for furnaces, hot water heaters, stoves and ovens, standalone heaters. Liquid propane is used in gas grills, obviously, lights for camping. So it's another fairly common type of fuel that we can use a portable extinguisher to extinguish fires of. Class B types of fires can be extinguished with carbon dioxide, dry chemicals, and a Class B foam. So we mentioned Class A foam when we were talking about the Class A fire extinguisher, and then Class B foam here for a Class B type of fire extinguisher. So get used to hearing the class of foam for A and B, because we have A and B type foams that are sometimes used on the fire apparatus as well. And the foams have different functions. They help extinguish the fire in a little bit different way, and they have a different chemical makeup in order to make them effective for the type of fire and the type of fuel that's burning for that type of extinguisher. As John mentioned, in that electrical room, they didn't want to use a certain type of fire extinguisher because there was electrical equipment. So you can see here the big X through the water. Once you turn off the power to the house, you can then use any type of extinguisher or Class A and Class B extinguishers. But Keep in mind that water, especially a straight stream or a smooth bore stream from a fire extinguisher or a fire apparatus, it can conduct electricity. And this is one of the reasons that it's extremely important to understand that the power is shut off, or you use a proper type of fire extinguisher or fire extinguishing agent if there is electrical, live electrical equipment in the area. All right, and then Class D fires. This is a little more rare, but actually probably a little more dangerous than Class A, B, and C fires. Because they're more rare, people have less experience managing and fighting fires of combustible metals and alloys. And what can happen here is if you hit a combustible metal fire with a water stream, it can actually turn explosive and cause severe damage and injuries to anybody that's nearby. Anybody know some areas or some material items that might be made of combustible metals?
Lithium batteries.
Tire rims. Uh-oh, John, we're not hearing you anymore.
Okay, can you hear me now?
Yes.
Good, good. Yeah, so vehicle wheels, high-end vehicle wheels are sometimes made of magnesium, very lightweight, but then if you get a vehicle fire, the front wheels are right near the engine compartment, the rear wheels are sometimes near the fuel tank, and there could be an issue with magnesium becoming explosive if you hit it with water if it does start on fire. Actually, there may be some of these materials in metal box springs in beds. And then potassium and sodium, chemical plants. I don't know if any of those materials would be used in like a grow house or a meth lab type of situation. But we have to be cautious of what types of materials are actually on fire so that we understand the best methods and the safest methods of extinguishing those fires. Okay. So this is just a repeat of what we just mentioned. Something to keep in mind, dry powder extinguishers work on Class D fires. It smothers the fire. But one thing that we want to keep from mistaking is dry powder does not necessarily equal a dry chemical extinguisher. We have the dry chemical extinguishers on our trucks, the ABC extinguishers, and these are the typical extinguishers that somebody will have in their home, but it's a dry chemical, not a dry powder. So it's a different material. It extinguishes the fire in a different manner. The dry powder actually will smother the fire, and by smothering the fire, we haven't gone through fire behavior yet, but does anybody know the things that are necessary for a fire to continue burning?
Oxygen, heat, and fuel.
Good. So what the dry powder does, it smothers the flammable metal, excludes oxygen, excludes air from coming in contact with the metal. The metal is the fuel. If you keep oxygen away from it, it should extinguish the fire. And that's what the dry powder type of material, type of extinguisher does. It smothers it. With a dry chemical, there is some smothering action, but there's also a chemical reaction that occurs to help extinguish the fire. So same but different, things that we need to pay attention to. So the dry chemical can, when it comes in contact with burning metal in a Class D type of fire, it can become explosive. And then the fifth one, class K, it's combustible cooking oils. So vegetable or animal fat type fires, extremely high temperatures, typically found in commercial and institutional type kitchens. Institutional meaning hotel, schools, hospitals, anywhere there's typical large groups that have meals. We have a number of those up here in Gilpin County. And occasionally there may be a small stove fire that people will have at home. So these type of class K fires can be controlled by wet chemical systems. For the larger systems, you can see up in the hood of this commercial range, these tubes that are protruding down from the hood, those are actually part of the fire suppression system. And it's hooked up to a large tank that has the wet chemical materials in this. It may be a heat or fire activated sprinkler, and there should be probably in this kitchen a fire button which would manually activate the fire suppression system in the kitchen. So as I mentioned a little bit ago, talking about the dry chemical and the powder type extinguishers, different methods of suppressing the fire can include the top one here, smothering, which excludes oxygen, cooling, which reduces the temperature. So if we remove heat, when we remove heat, we remove one of the legs of the fire triangle. If we induce a chemical that interrupts the chemical chain reaction of the fire. And then there's another called saponification, which is it's a chemical process that forms an oxygen excluding foam. So it's a type of smothering, but it's for certain types of flammable materials. And the saponification, it forms a soapy type of foam surface and very conducive to eliminating the oxygen contact with the material, the fuel material. And by doing that, then it's left or eliminated one of the three legs of the fire triangle, and the fire goes out. Okay, so fire extinguishers, they have various mechanisms in order to push the fire suppressing material out of the tank. So one of the first ones here is the manual pump. Physical pressure forces the agent out of a nozzle. So does somebody know, has everybody seen a manual type fire extinguisher? One type of manual fire extinguisher is the water bags that we use on wildland fires. It's usually a yellow colored pack. It has a hose and then a hand operated manual pump. Sometimes they're called piss packs. They have shoulder straps on them. We will carry a few of these into a fire sometimes if we need a little bit of water to be able to do some suppression work. The second type of extinguisher is a stored pressure extinguisher. There's a compressed air or some type of inert gas that is stored inside the cylinder in contact with the suppression agent or the suppressing material, whether it's water or a dry chemical. Excuse me, when the nozzle is opened, the pressure of the air or nitrogen or CO2 pushes the extinguishing agent out of the nozzle. Very simple. So the water cans, excuse me, the silver water cans are a stored pressure type of extinguisher. They're actually pumped up either using compressed air in the station, or you could use a simple bicycle pump to pump it up to typically around 100 to 110 psi. These have gauges on them so that they can be readily seen whether they're in service or not in service. And then when they're used, they can be repressurized very easily. At least the water cans can. We can refill the water, we can repressurize it, and that gives us an opportunity to use these for practicing. And then the third type is a pressure cartridge. This is a type of extinguisher where the pressurizing gas is separate from the extinguishing agent. And then when this type of extinguisher is to be used, I am so sorry about the audio problems, everybody. Did everybody hear the stored pressure information?
Yes.
Yeah.
Okay. So then the pressure cartridge type of extinguisher, it has two tanks. One tank has the extinguishing agent, and there's a second smaller tank that contains the pressurizing agent. So it will typically have compressed CO2 or nitrogen. So to use this type of extinguisher, there's a valve that is opened. It pushes the expellant into the container where the suppressing agent is, and then it allows the suppressing agent to move out of the nozzle. So this was that first type of extinguisher or pump that I was mentioning. You can see this firefighter has this is a yellow pack on the back, the shoulder straps, and then this is a manual pump. So this is the handle to the pump, which has a nozzle on it. And this is the stationary section. You can see the tube that goes to the bottom of the pack around the firefighter's back. And then this is just moved in and out, and it allows the firefighter to shoot a pretty decent stream of water. They'll sometimes have two different nozzles, a straight stream nozzle and then more of a mist type nozzle, depending on the type of material and the type of fire that's being extinguished. Stored pressure water extinguishers. These are, everybody has seen these before. We have one of these on each of our engines and tenders. You can see this has the tank itself. Usually they're 2.5 gallons. They're 2.5 gallons. The hose with a nozzle on the end. Hello? This is the stationary handle. This is the handle that activates the valve. There's a safety pin that goes into the handle that prevents it from being inadvertently activated. And then this is the gauge. You can see the gauge has a green section with a needle in the gauge that will indicate whether it's overpressure at the appropriate pressure or lower than normal service pressure. All right. So you can see the firefighter in the photograph here. There's a small Class A type fire, probably just some papers. You can see the stream from the water can extinguisher has a pretty good reach to it. I bought one of these for our house a couple of years ago and messed around with it before I, quote, put it in service, unquote. And it'll shoot up to 50 feet. We'll give anywhere from 30 to 50 seconds worth of flow. So it's a pretty significant firefighting tool. Probably more house fires have been put out with a water can than have been put out with trucks. So when we have a call to a wood burning stove fire, pellet stove fire, or just a smoke smell in a house or any commercial building, this will be one of the tools that we take off of the engine, and it's one of our standard first line firefighting tools. You can see the firefighter here. He has proper PPE, so he has full bunker gear, gloves, head, helmet, and face protection. So similar in appearance, a water mist stored pressure extinguisher can be used on Class C fires. And you can kind of see the difference here in the graphics. Deionized water has less of a conductivity situation than normal water does. So in this case, if you just looked at these fire extinguishers, they look the same. So it's extremely important to read and understand any labeling that's on the extinguishers. If this has deionized water and it has a mist nozzle on the end of the hose, it'll say Class C type fire extinguisher. The normal Class A type water can extinguisher will say Class A on it, but it'll have just normal tap water in it, and it'll have a straight stream nozzle. So mistakenly using a Class A type extinguisher on a Class C type fire could be very exciting or extremely dangerous. So the electrical current can actually flow down back from whatever the electrical apparatus is that's on fire, can flow electricity back through to the extinguisher and shock, injure, and or kill the firefighter and or somebody right near them. So understanding what type of fire extinguisher you're using is extremely important. Read the labels, read the instructions, understand it, and internalize it. Sometimes in a Class A extinguisher, there'll be foam that's used. That should be a specific type of extinguisher, specially designed for use with foam. Foam can sometimes gum up the valve mechanisms, and a Class A extinguisher that uses foam will usually have a different type of nozzle. So the nozzle is specially designed to flow the foam water mix better. What the foam does, it reduces surface tension. So it allows the water to contact the surface and soak into materials more quickly. And that helps to extinguish the fire as well as keep the fire out. If there's smoldering materials nearby, if the material is allowed to absorb the water more, there's less opportunity for rekindling of a fire. Okay, so here's a third type of silver fire extinguisher. You can read the label here. It says K-Guard. Extremely important. Read the labels, understand what tool you have before you start using it. You can see this is probably in some type of commercial kitchen, being stainless steel counters, and might be an oven or something of that sort. So a commercial kitchen or a larger residential kitchen may have a built-in K-type extinguishing system or a manual handheld portable fire extinguisher. As it shows here, it's a potassium-based low pH material. It interacts with the oxygen and creates a layer of foam that will keep the oxygen away from the burning oils. So if this foam layer is broken, you could have a potential rekindle on the fire. So understanding the type of material that's in the extinguisher or being used in extinguishment of the fire is important. There are certain types of other other types of foams that are used off of engines, where there's different techniques that are used in order to maintain the foam layer on top of the burning material. If that foam layer is broken, the material can rekindle and start on fire again. So extinguisher use and fire extinguishment in general is not just a spray and pray type of situation. It's an understanding what the material is that's burning, what the material and the tool is, the extinguisher material being used to extinguish the fire, and then how to use this to put out that.
John, I have a question.
Yeah.
Does like putting salt or baking soda on a grease fire in the kitchen, is that working by saponification as well, or do you know?
You know, I don't know exactly, but baking soda, I'm guessing, is a low pH material. So a low acidity or a base type material. We'll have to look that up. But that is something that I think I've heard in the past. And if that is, then it would go along the lines of this low pH type of material, even though it may not be potassium based, to create some sort of layer on the oil or mix in with the oil in order to create a layer to eliminate oxygen from the burning process. I made a note and I will look that up for everybody. Okay, some fire departments do carry K-type fire extinguishers on their rigs. We don't here at Gilpin. We have very few commercial type kitchens, and we have other ways of dealing with the low frequency types of low frequency and low small size type of cooking oil fires. So aqueous film forming foam, AFFF, used on Class B fires. So small liquid fuel spills. And here you can see with these arrows, what we're trying to do is we have the fire, which is this orange ball here. Use your imaginations. We have a AFFF Class B extinguisher. Here is a pile of foam. So what they're showing here is, as I stated earlier, we want to try and smother the fire and to cover the burning material with a layer of foam. So what they're doing here is they may be creating a pile of foam and then push that pile of foam up and over the burning area to create a blanket over the top of the foam, over the top of whatever the fuel is that's burning. If they sprayed the extinguisher directly on the fire, the foam will splash all over, splash up, and then splash back down and not adequately smother the fuel-air interface. The two arrows up on top here is a banking method. So you can spray the foam against a barrier. It could be the outside of a tank that's ruptured. It could be the outside of a vehicle, and cause the foam material to bank down on to the burning area and create a layer of foam on top of the fuel that's burning and the fuel that's not burning. So what we're doing is we're totally encasing all of the spilled fuel with the foam. It's excluding oxygen. One of the legs, one of the sides of the fire triangle will be eliminated and the fire should go out. if somebody mistakenly sprays the extinguisher directly onto the spilled fuel, what they can do is they can break that layer of foam. It will get contact, it'll allow it to come in contact with oxygen again, and the fire can potentially start up again. So we'll talk about this more, different methods of using foam in order to enclose and blanket the fuel in order to smother the fire, as well as to eliminate oxygen from the process. All right, clean agent extinguishers. They've replaced halogenated extinguishing agents. So a material that a lot of people may have heard is halon, and was used in computer rooms and aircraft engines, areas that were very easily damaged by water or dry chemical agents. So when computer rooms started becoming very prevalent in many businesses, 30, 40 years ago, the computer room was one of their high profile, very expensive risk areas in a business. And if a fire started in the computer room, and dry chemical or water was used to extinguish the fire, obviously the computer and all of the equipment in that room would be essentially destroyed. Water obviously is damaging and dangerous in electrical room fires. Dry chemical, just one second squirt of a dry chemical extinguisher will literally coat the entire inside of a compartment. And no matter how well you clean that compartment, for years afterwards, you're going to be finding the dry chemical extinguishing agent in nooks and crannies and in every square inch of that particular compartment. So because computers were very high value, they wanted to come up with a different type of extinguishing agent. So one of those was halon, used early on. Another one of the downsides to halon was it has a damaging effect on the ozone layer. So a bunch of years ago, when chlorofluorocarbons and other materials were found to be damaging to the ozone layer, a different type of material had to be found to be effective for these types of fires. So non-conductive, safe on energized electrical equipment. It cools and smothers both Class A and Class B fires, and rapidly evaporates, leaving no residue. So it essentially is non-damaging if it's used, excuse me, in those types of fires. Another type of pressurized type of fire extinguisher is the carbon dioxide. Both handheld and wheeled units. You might have seen some old-fashioned type units that have two large wagon wheels. I don't know if I have a picture of it here. Not readily available. You may see these at airports. They can be wheeled quickly to the scene of a fire. Carbon dioxide, it's effective on Class B and C fires. It's non-damaging to electrical equipment. No freeze protection is required because obviously it's carbon dioxide and there's no water inside of it. But as with anything, it has pros and cons. Some of the downsides is carbon dioxide extinguishers have limited reach because it's a gas that's being expelled out of the bell of the extinguisher nozzle. And because it's not a material or a liquid, it's a gas, it can be easily dispersed by the wind. So using a carbon dioxide type fire extinguisher outside is sometimes going to have very limited effect on the fire itself. So carbon dioxide, it smothers the fire because it excludes oxygen. You can see here this big cloud of CO2 is pushing the O2 out of the way. So it's pushing the air out of the way. Because it is a gas, it has very little cooling effect. Water actually absorbs heat. Dry chemical can actually absorb heat and has a chemical reaction within the fire chemical reaction, and it helps to, the dry chemical itself helps to eliminate the fire chain reaction. While carbon dioxide has very little cooling effect because it is just a gas. And then once that carbon dioxide is dispersed, which happens very quickly, if there's still heat, reignition is definitely possible. Another thing to remember with CO2 extinguishers is that an electrical static charge can build up on the discharge horn. So be cautious of that. I don't remember if Ward found any CO2 extinguishers here in Timberline's equipment. We had one or two that we practiced with last academy, but I don't know if we have any that we can mess around with this academy. But just be cautious. Something to remember if we do find one, and if we do end up using it for training, or if we end up using it on an incident, we want to be cautious about this electric charge and shock potential. Here we go. This is the large size wheeled CO2 extinguisher. Has a handle, a couple wheels. This is probably 4 or 5 feet tall and has quite a large quantity of CO2 in it and can be used very effectively for the appropriate types of fires in the appropriate type of atmosphere. Any questions to this point? Comments?
Do we carry CO2 extinguishers on any of our engines?
We do not. In the past, we have, but very rare. And it's, I don't know that we have any left in the, in Timberline's inventory. Because of its limited effect for the types of fires that we typically see here at Timberline, it really doesn't make a lot of sense for us to have these on the rigs. So if you do see one, it's kind of an anomaly, and somebody may have either mistakenly or just tossed it on a rig just in case. But it's not part of our normally dispatched equipment. Up here we have, we don't have many potential incident locations where CO2 would be the preferred method of extinguishment. And because we have quite a lot of wind, using it outside would not be very effective.
How is
Awesome, thank you.
how is the static electricity buildup ultimately discharged when they are used?
The proper way would be just to touch the horn to the ground. And then the electrical charge built up in the extinguisher itself and in the horn would go to ground. Or you can just ding the firefighter next to you on their leg or something. All right. So getting into the dry chemical extinguishers, there's the typical that we see is the multi-purpose ABC rated dry fire extinguisher. So A, B, and C, it has the capability of being used to fight practically any type of fire that will be seen in a household, in a business, as well as anything that we may see on any of the incidents that we see here in Gilpin County. You may find somewhere a BC rated dry chemical extinguisher. So you have to be cautious because this is not rated to fight fires of normal combustibles. So it'll probably be a specialty type of extinguisher in a specific business or an industrial situation where they don't have A-type combustibles and they have more electrical and gas and liquid fuel type situations. Something to keep in mind when owning or maintaining dry chemical type extinguishers is that most of the dry chemical extinguishers that we have here in the district are the stored pressure type extinguishers. So the pressure is inside the same container as the extinguishing agent. So if this extinguishing agent is a very fine powder, and if it sits for a long period of time, it can cake up. So if the powder is all caked up and you attempt to use the extinguisher, it may not work well and you may not have all of the material inside the extinguishing agent available to use. So we have to be cognizant when we are maintaining both our personal and the dry chemical extinguishers in district, that we have to do things to prevent them from caking. Now, anti-caking agents are added, but sometimes it's not quite enough to prevent caking. We have to make sure the material stays free flowing. And to do that, we can tip the extinguishers over, shake them, and you can feel the material inside the extinguisher moving. So doing this a couple of times will allow the material to uncake and will keep it from potentially clogging when it's wanting to be used. Dry chemical extinguishers can react with other types of extinguishing agents, as was noted earlier. So we want to be very situationally aware that we never mix different types of agents. A particular type of agent for a particular type of extinguishment on a particular type of fuel. And there they say it again. Dry chemical agents are considered non-toxic and safe for use. We have to be cautious though, because they can reduce visibility. They can create respiratory problems. And we have to be careful because they might not be compatible with foam. When we use foams, we talked about the foam smothering the fire and eliminating oxygen from the fuel material. So if we have a foam layer down and we use a chemical, dry chemical agent, we may harm that foam layer and open up the opportunity for the fire to rekindle. So speaking of the visibility degradation that can happen when extinguishers are used, this is a photograph from 2 years ago, I think, over by Station 7. And you can see when you get a couple of these extinguishers going, it significantly reduces visibility. When the wind shifted out of the south a little bit, we had to be careful because it was blowing over Highway 46 and we had issues with some vehicles going by. So that's just something to keep in mind as we do have an opportunity to start using these for training as well as for use on incidents. Keep that in mind, and you'll be situationally aware if we get to a point where we're using this much CO2 or dry chemical. So following the following steps when using a dry chemical extinguisher on a Class A fire. We want to direct the discharge at whatever's burning. After the flames are knocked down, apply it to the smoldering area. So we haven't talked about it yet, but does anybody know the acronym for these steps in using an extinguisher?
So the steps for using an extinguisher are, it's called PASS, the acronym.
Yes.
Pull, aim, squeeze, sweep.
Very good. Excellent. And we'll go through that in more detail later, but it's fun to hear if somebody has some knowledge that they can share with the group. So handheld dry chemical extinguishers come in two basic designs. The two basic designs of a handheld dry chem extinguisher. We talked about it before. The cartridge operated, where first the pressure cartridge is connected or it's activated, and then the tank is pressurized once the pressure goes from the pressure cartridge into the tank with the extinguishing agent. The other is the typical ones that we have is the stored pressure. So as with anything containing or that is pressurized, we want to be extremely cautious. So we're dealing with a typical dry chem extinguisher of around 200 psi. Even the water can at 100 psi can be dangerous if not handled properly. If a pressurized cylinder is damaged or dropped or handled aggressively, it can emit, if the valve is broken or the cylinder itself is ruptured, that 200 psi or 100 psi or whatever the particular container is can cause significant injury and or death. So as we're handling extinguishers, be extremely cautious and don't handle them recklessly. So in your typical stored pressure extinguisher, we have, in this case, it shows water, but it could be the dry chemical or the dry powder, and that just sits down in the bottom of the cylinder. We have pressure, whether it's air, nitrogen, or carbon dioxide. And when the pin here is pulled and the handle is squeezed, the valve is opened. It allows this stored pressure to push the extinguishing agent and then out and up through the tube, out through the hose, and out through the nozzle. So another thing to keep in mind, depending on the type of extinguisher, is you want to keep it in the proper orientation. If I turned this extinguisher on its side, do we think it would work as well as it does when it's upright? If the extinguisher is turned on its side and this tube goes above the level of the water or the chemical inside, all the air or the stored pressure will just escape through the tube and the extinguisher becomes useless. So understanding the tool that you're using, in this case, the tool is the extinguisher. We want to make sure to use it properly, keeping this upright or as upright as possible in order for it to work effectively. Okay, in the case of a cartridge operated, In this diagram, the cartridge is internal to the extinguishment material cylinder. Sometimes we'll see a cartridge on the outside of the cylinder. So normally this is sitting on a rack or sitting on the floor. This chemical, and there's either just air or a vacuum inside the upper part of the cylinder, but there's no pressure. So once the extinguisher is activated, the CO2 gas cartridge is opened, it pressurizes the inside of the cylinder, pushes the material, the extinguishing agent, up the tube on the inside, out through the hose, and then out through the nozzle. So very similar, but different. In the case of these, if you didn't pay attention to the labels, and if you weren't familiar with the type of mechanisms on the top of the cylinder, normal everyday Joe would probably mistake these for one and the same. So this is a picture of different sizes of stored pressure, or I'm sorry, the cartridge operated type of extinguisher. Just another style. Ansel is the brand on this one. So as I mentioned earlier, if the extinguisher is not properly maintained, is not properly assembled, it could cause damage or injury or death. Because there's no pressure on the inside of this cylinder, if this cap is not assembled properly and tightly, and the pressure is released from the pressure cylinder into the extinguishment cylinder, all of a sudden this cap has pressure. Okay, until the pressure is released from the pressure cylinder into the extinguishment cylinder on these types of cartridge extinguishers, if this cap isn't assembled properly, it could become a projectile or gas and extinguish. So this caution becomes important, keeping your head or any other part of your body away from the top of the extinguisher, because it can cause an injury if something goes wrong. Same can be said with the water can type extinguishers. When you're working with them and assembling them, just take the extra situationally aware second to pay attention to how you're positioning the extinguisher relative to our bodies. We don't want to be looking right down on it as we're filling it and pressurizing it, because it can cause injuries. So for larger units, similar to the handheld units, a wheeled type dry agent extinguisher, you want to make sure that the hose is stretched out completely so that the powder doesn't clog or jam up inside the tubing. There's going to be nozzle reaction. So as the extinguishing agent comes out of the nozzle, there was an equal and opposite force pressing the nozzle backwards. So maintaining control of the hose and the nozzle is extremely important. And we'll learn a lot more about that once we start talking hoses. But even in these small type of extinguishers, we want to pay attention, hold the hoses and the nozzles tightly, and be prepared for again, caution, be cognizant of what you're doing, who's nearby, and any potential danger aspects of the type of extinguisher that you're using. So dry powder extinguishers for Class D combustibles. Remember, we need to understand what type of extinguisher we have and what type of fuel we're working with. So this extinguisher says Metal X for Class D. Metal X for Class D type fires only. Remove the hose, push on the lever, stand back 3 feet, squeeze the nozzle. So this is a dry powder extinguisher. And we talked earlier about dry powder versus dry chemical, right? So dry chemical actually creates a chemical reaction to extinguish the fire. Dry powder, it smothers the fuel material, eliminating oxygen and causing the fire to go out. So understanding and knowing what the material is. So if we're using this on a set of magnesium wheels that were over at the automobile repair shop here next to the transfer station. So maybe Kaiser was working on a couple of high-end vehicles. He took the wheels off and was working on the suspension system, and he was doing some welding, and some sparks got into the leaves and weeds and pine needles in the bottom of the shop, and the magnesium wheels started on fire. Obviously, we want something appropriate for a Class D type of fire. So a Class D type of fire extinguisher, or there may be some extinguishing media that's in a bucket where you can scoop it on to cover whatever's burning and smother the fire. So obviously consult the manufacturer's guide, find the guide, read the instructions, learn about the type of extinguisher that you have available. Because we're smothering the fire, we want to be sure that we have enough extinguishing agent to do the trick. We have to apply sufficient depth. We want to apply it gently. We want to apply enough material to the burning fuel in order to cover it. We don't want to break the crust once a crust does form, and we want to avoid scattering. So fancy graphics. So over at Kaiser, they, for some reason, had enough of a Class D type fire extinguishing media. They cover up the magnesium wheels. Oxygen is kept from contact with the wheels. So we have removed one of the fuel, oxygen, or heat legs of the triangle away, and the fire will go out. Don't break the crust because the material is still probably hot. So if oxygen is reintroduced through a broken crust, it could reignite. Remember, combustible metal fires can become violent if water is introduced to the situation in the incident. So if a small amount of burning metal is on a combustible surface, you want to first cover the material with powder, layer it appropriately deep, add more as needed, and then leave it undisturbed until it cools down. once it's cool, if the material is cooled below the ignition temperature and oxygen then is reintroduced, it shouldn't start on fire because there's not enough heat. So when we get into fire behavior, we'll learn more about the heat, oxygen, and fuel triangle, as well as the chemical reaction aspect. But that's something to start internalizing because we'll be talking a lot about that over the next few weeks. So portable extinguishers have ratings, and their ratings are according to the performance capabilities. So you can see Class A Class A extinguisher. They have the typical sizes, 1¼ gallons. 1¼ is a strange number, but 1¼ is a strange number, but it's actually geared toward the 5-liter volume, and then double that is 10 liters, about 2½ gallons, which is our typical silver water can type extinguisher. Class Bs, they have different ratings based on the approximate square foot area of a flammable liquid fire a non-expert can extinguish. So a 1B rated fire extinguisher should be able to, by the typical person, extinguish a 1 square foot fire. So a very small type fire. Maybe you spilled, you're refilling your gasoline in your lawnmower and the top of the lawnmower is on fire. That might be 1 square foot. You have a Class B rated, a Class 1B rated fire extinguisher handy. A non-expert should be able to extinguish that burning lawnmower in an appropriate fashion. And then obviously getting up to a 640 B rating extinguisher, it's going to be quite a large extinguisher. For Class C type extinguishers, the only performance rating that they have for that is a non-conductivity type of rating. So there's no specific capability test or no approximate square area, but they obviously want to assure that the extinguishing agent is non-conductive. Class D, similar type of situation where they test for toxicity, metal burnout time, and reactions. To have the effectiveness against a 2.25 square feet of light cooking oil in a deep fat fryer. So a typical, typically sized deep fat fryer with a normal size K-type extinguisher should be effective. If you have a large cooking situation, then a larger or a built-in type of system would be required in order to effectively meet code probably, as well as extinguish a larger deep fat fryer type of fire. So this is just a summary. Class A type extinguishers based on the amount of agent, duration, and rate of discharge, range of discharge. Class B's approximate area a non-expert can extinguish. Class C's just non-conductivity. Class D's what type of combustible metal you're dealing with. And then Class K, can it saponify cooking oils? So understanding and memorizing the different types of materials a specific class of extinguisher can extinguish is going to be a question you'll probably see both on the state test and in the Timberline test. So figure out a way of memorizing those details, and you'll be in good shape for the test. So some extinguishers have combinations, and it's called multiple markings. Class A, B, C, A, B, B, C, and then some for a specific class. Note that the ratings for each class, they don't affect each other. So if an extinguisher is rated for ABC, it has to meet the requirements for A, B, and C inclusively. So having an A rating or having an ABC rating does not reduce its effectiveness fires that this extinguisher is intended to be used. Don't use an extinguisher on a class of fire that it's not intended for. So if you have, by chance, a class type AB extinguisher, don't mistakenly think that it can handle a C as well, because it's not rated for electrical conductive type of fire. And then the same for class type BC. So here are some of the symbols that we may see on the labels on fire extinguishers. Now every extinguisher should have a label on it that details the type if it's a type of extinguisher that has a specific time frame that it can discharge over. It may have an image symbol as seen in the white and blue here, which is a pictograph that is hopefully understood by the normal layperson. A, for example, it's materials in a trash can, and then a campfire or a fire with wood, and it should have some indicator of the type of fuels: wood, paper, plastic, rubber, cloth. So as you start taking a look and paying attention and are more situationally aware of fire extinguishers after tonight, take a look at it. Check to see what the label says. If there's a label missing, then that's an issue, another issue above and beyond just understanding how to use an extinguisher. Pay attention in your offices, if you're working in an office these days, or once you do come up to the stations. Each of our stations has fire extinguishers as well as the extinguishers that we'll find on the apparatus. So pull them off, take a look, learn what to look for, learn what the labels say, so that it becomes more or less second nature to get a feel for what an ABC type of extinguisher looks like. What are the markings so that you can understand the type of extinguisher, and then learn the type of fuel that that extinguisher should be able to be used with. How's everybody doing? Do we need to take a break? Hit the restroom, grab a drink?
I think a break would be nice.
Okay, I have 7:45. 5 minutes enough, or do we need more?
5 is good.
Good.
All right, let's see everybody back here at 1950. That's 7:50. Okay, is everybody back?
Yes, sir.
Yes, sir.
2. Give a flash to your camera or let me know somehow.
I'm back as well.
3, 4.
I'm back.
Jones is back.
Okay, I had a question from Scott, and he was asking, let's see, he said, since a lot of wood stoves have electric blower motors in them, is a Class A water can the best choice, or should you choose a Class C extinguisher? How much of an electrical hazard do the little blowers create? It's a good question. Those little blowers, you know, in any type of stove that's plugged in is 110 volts. So it is a significant risk, even though the fan itself is real small. It's still an electrocution hazard. So in the case, if we were taking an extinguisher into a house that had a smoldering or a fire going in that type of device, you'd want to make sure that you were using a non-conductive extinguishing agent. So another thing you can do is unplug it or shut off the electric. If it's a built-in fireplace or wood-burning stove, the wiring may be built in, but there may be a switch, above the fireplace or off to the side that controls the blower fan itself. So making sure that's off, or turning the circuit breaker off on the outside of the house, or if there's a breaker box inside, would be critical before using a water can, if that was the only method of extinguishment that you had. So if you turned off the electricity, you could use the water can. Other methods is you could close the stove doors. Of course, you could turn the electric power off to the blower and then use a water can. You can use a dry chemical fire extinguisher, although they tend to make a huge mess. As I said, if you use a dry chem extinguisher inside a house, that whole room is probably going to have a coating of yellow dry chem powder in it, essentially forever. So we want to, actually that brings us to this slide that's up right now. So what we want to do is we want to minimize risk to life and property, as well as minimize damage for the homeowner while we effectively extinguish the fire. So doing everything and using all of our knowledge to create a safe situation to use with the tools that we bring to the incident is extremely critical. Sometimes life and death. Hitting a, if you inadvertently sprayed a wood burning stove that has a blower that is still powered, it could literally kill you with the electricity that will come through that solid stream water from the extinguisher. So Scott, did that answer your question? Scott?
It looks like you put it in the text chat. Yeah.
All right. Can everybody still hear me okay?
All good.
Great, thanks. And again, thanks for bearing with us on this. Okay, so we want to talk about selecting proper fire extinguishers. This is kind of bringing it all together, everything that we've talked about this evening. We have to get an understanding of what is the fuel classification that is burning. What is the rating of the extinguisher? Did we grab the extinguisher that was appropriate for the class of fuel that is on fire? What hazards have to be protected? You know, there may be, as we just talked about, there may be electrical hazards where a water can is not appropriate. There may be hazards where a water can is not appropriate. So then we would have to, if the water can is the only thing that we had available, then we would have to determine a different method of extinguishing the fire. How large is the fire and how intense is it burning? We talked about size of fires certain extinguishers are appropriate for. If you know a house or a compartment in a house, a room in a house is fully involved, or there's a couch that is burning, somebody left a cigarette smoldering in between the cushions and the couch itself was burning. Now, fire extinguisher may be on the low edge of tools capable of extinguishing that fire. What are the atmospheric conditions? Is it really windy out? Is it cold out? Is it hot out? What type of training do you have and does your crew have for the tools that you have for extinguishment? You know, are you trained on that type of extinguisher? Do you know how to use it? How easy is that extinguisher to use? If it's extremely complicated and you haven't been trained, well, you may not be as effective as you could. Are there life hazards present? And then operational concerns. So just reiterating, in areas where highly sensitive computer equipment is located, don't use a dry chemical, don't use a water extinguisher. We want to use a clean agent or carbon dioxide, CO2 type of extinguisher. You see here 5 different types of extinguishers, and they all have instruction labels as well as inspection tags. Extinguishers by NFPA are supposed to be inspected and serviced in specific time frames. So any extinguisher that you have control over or that you see, take a look at this tag. It should have a company name and a date when it was inspected or serviced. So while all of these look very similar and they all have a handle on top where you pull for the P and you aim the nozzle for the A and you squeeze and sweep, they have a little bit different usage instructions depending on the type of extinguisher. So make sure that you learn, read, and become competent on any type of extinguisher that you may be using. Yeah, Johnny.
I was hanging out with Ward this afternoon, and he writes a lot of the test questions, and he made sure that he kind of hit home on certification timeframes on the different extinguishers, with ABC being 6 years and A water ones being 5 years. Just FYI.
So that was 5-year lifespan or 5-year till it has to be hydro tested?
5 years for hydro tested,
Okay.
and 6 years for inspected, for dry chemical, and I think it was 12 years for their lifespan for kind of ABC ones. So maybe a test question.
Yeah, good hints. And again, make sure you're reading and studying the Essentials book, because all of the Colorado state test questions will be noted in there. But as Johnny noted, Ward Watson has been on the, I don't know if it's a committee or a board that manages Colorado State JPRs and tests. And he's been doing that practically forever. And so when he mentions something and gives you a hint or a tip, make sure you either remember it or you jot it down so you can go back and review it, because it's a good indicator that you'll probably see it on the state tests and or on the Timberline internal tests. Thanks, Johnny. Okay, so we have a note here where full structural or wildland firefighting PPE. We've been hearing the term PPE a ton lately, including a proper respiratory protection when operating any portable fire extinguisher. And the reason for this is not necessarily that the extinguishing agent coming out of the extinguisher will be harmful. It can be irritable, especially if you're sensitive with allergies. But something that a lot of people don't think about when they're using an extinguisher is the gases and the smoke and the byproducts of combustion coming off of whatever is burning that you're trying to put out. So if you properly approach the fire with the extinguisher upwind, upstream, uphill, and the wind kicks around and gets swirly, then you're going to get a face full of smoke and toxic gas. And toxic gases, the off gases from certain materials, even a few breaths of that can be extremely damaging to your lungs or mucous membranes in your nose, your mouth, and your eyes. So whenever possible, be smart, be situationally aware, and take appropriate precautions. If you're asked or if you are charged with grabbing a fire extinguisher off the rig or out of a building or off the bracket in your house, you want to do a few things as you grab it. Make sure that it's charged. Take a look at the valve, the gauge, make sure that it is charged and operable. Feel the weight of it. Skipping back down to the third picture there. If an extinguisher has been discharged, especially a water can like the one this guy is holding, then it's going to be significantly lighter weight than if it was full with the 2.5 gallons of water. Even a dry chemical extinguisher will be lighter weight if it has been discharged. Take a quick look at the hose and the nozzle. Make sure the hose is intact, it's not cracked, dry rotted, exposed to ultraviolet light, and make sure the nozzle is in place, is not cracked, and is not clogged. And then the fourth, I mentioned it already, but check the pressure gauge. You don't want to take a disabled extinguisher into an incident because obviously you could get yourself into a situation that you don't have protection for yourself or your crew members. If we do go to an incident where a water can or a handheld extinguisher is appropriate, and we go in expecting to put the wood burning stove fire out or the little fire in the trash can, and we take in an extinguisher that is not operable and should have been checked but wasn't, what's going to happen? That fire is going to grow. We're going to have to go back out to the rig to grab another fire suppression tool. The fire may grow to a point now where we can't handle it with just a handheld extinguisher. Somebody could get hurt. So doing your truck checks, first thing when you arrive on shift, checking extinguishers that are in your house, checking extinguishers in any of the buildings that you work at is extremely important. It's not just a, oh, well, it didn't work kind of thing. It can have significant ramifications. All right, so general steps for using an extinguisher. We talked about the PASS. Some additional points on that is approach with the wind at your back. It's easy to see. The flames will be blowing towards you if the wind is towards your, in front of you. If you have a headwind, the smoke will be coming towards you. Move around to the side of the fire, to the back of the fire, because you want to approach it with the wind at your back. This will keep the smoke from contacting you. It will also keep the extinguishing agent in a good stream pattern. If you're discharging the extinguisher into the wind, this will all blow back at you, and you'll have to get too close to the fire. The fire will be blowing at you. You'll be extinguishing into the wind, and it's going to be an ineffective situation. So pull the pin, approach the fire, wind at your back, understand what distance you need to be from the fire in order to be effective with whatever type of fire extinguisher you have, and then sweep. So you're sweeping the base of the fire, trying to cool it. If you have a water can, trying to cool it and trying to smother it and cover all burning surfaces with a dry chemical, if that's the type of extinguisher you have. Obviously, if you have a real small extinguisher, you'll have to be closer. It'll have less range and less extinguishing media. So you want to be a little bit closer with a smaller extinguisher so that you, as soon as you begin to attack the fire, all of that extinguishing media will reach the fuel that's burning. Operating close to the fire can scatter coals and fuels around. It can also penetrate the surface of liquid fuels. So you want to apply from a point where it reaches but doesn't disturb the fuel surface. Obviously, releasing the handle will stop the flow of the extinguishing agent. So you don't have to use all of the contents of the extinguisher in one shot. After the fire is reduced in size, you can take a step back if you haven't used the entire extinguisher. Understand, is the fire completely extinguished? Is there still smoldering happening? Is there still flame present? If, for example, we had a call to a campfire this evening, if by chance those guys took a extinguisher into the campfire, to the campsite, and they only have 2.5 gallons in a water can. So what we'll typically do is we'll squeeze, sweep, not use the entire extinguisher, but then we'll term overhaul. We'll take a tool and we'll mix up the fire bed itself. So exposing any coals that may be underneath and still hot, mixing in the water with the warm or the hot coals. And this helps to cool, helps us to understand, is the fire completely extinguished? And it helps to increase the usefulness of the water that's been sprayed into the fire, because sometimes it'll just sit on top, won't get down to the deep hot sections of the fire, and you could have a mistaken understanding that the fire is completely extinguished when it's not. So this is a reiteration. We want to make sure that we reach the fire with the extinguishing agent approaching from upwind. Apply it from an appropriate distance. And what is the appropriate distance? Well, we'll have an opportunity to practice with portable extinguishers once we start our in-person JPR programs. And then studying and reading the directions and the instructions on the extinguisher will sometimes give us an understanding of how close we need to be to the fire for the extinguisher to be effective. And then after the fire is reduced in size, this is where I mentioned we can use an appropriate tool to overhaul. If we have a liquid fuel, we may have to apply foam. Keep in mind, extinguishers are first aid appliances. We can use more than one if necessary and it's appropriate. And then, excuse me, once the extinguisher is used, if we're at a scene of an incident, lay the extinguisher down. That's the universal signal that it's been depleted and has been used and is no longer in service. So getting into Ward's side of fire extinguishers, and one of his significant tasks here at Timberline is inspecting, carrying, and maintaining extinguishers. There's an NFPA, number 10 is a list of all the guidelines that fire departments should be taking with respect to portable handheld extinguishers. Sometimes jurisdictions, the AHJ will have a local SOP. AHJ is authority having jurisdiction, and then SOP is standard operating procedure. So sometimes fire departments or counties will have requirements that are a little bit different or above and beyond NFPA. And then if it's a privately owned extinguisher, there may be codes that the county or the city or the town has with respect to extinguishing tools in privately owned or in businesses, privately owned residences or businesses. So NFPA requires at least an annual inspection. Serviceability, accessibility, and simplicity of operation are three things that go into the rules and regulations that manage portable fire extinguishers. So as far as location, you want to have an extinguisher that's in an appropriate location. You don't want it inside a closet. You don't want it inside a cabinet where it's not seen, buried under a pile of something in the back of a garage. It should be accessible nearby where a potential fire can ignite, and or near entrances, which are also exits. You want to inspect the nozzle of the horn, making sure it's unobstructed. We talked about the hose free of cracks, keeping it clean. Keeping it clean, free of grease and oils. Oils and greases can sometimes attack the rubber or the plastic material of a hose or a nozzle. And then obviously the shell or the cylinder free of damage. Dents or dings can affect the serviceability of an extinguisher because we're dealing with high pressures, very high pressures in the case of some of these extinguishers. I mentioned the So for every extinguisher inspection, you want to make sure the instructions are legible. The seal and the pin are not tampered with. So the pin will typically have a safety wrap around it. And what happens then, a lot of times is kids will mess around and pull the pin and break the safety wrap or the little zip strip that holds the safety pin in place. And just looking at it, you don't know if the extinguisher has been tampered with or not. And somebody may take it out and play with it and then put it back in the rack. And unless you check the gauge and check the weight, you don't know if it's fully pressurized and filled. So if it is deficient by more than 10% in weight, it should be removed from service. And then, as I mentioned earlier, check the inspection tag. If the tag is there, it should have a current inspection. Extinguishers are something that people don't pay attention to, and over the course of time, years can go by where an extinguisher is out of inspection and should technically be taken out of service until it is inspected and maintained. So if anything is found to be deficient, the extinguisher should be removed from service and replace it with an operational extinguisher. You don't want to leave a potential exposure without proper fire protection. If it was important enough to have an extinguisher placed in a location in the initial time, it's important to have an out of service extinguisher replaced with one that is in service. And then report the need for service to whoever the appropriate individual is or department is. In this case, if you see something out of date or that should be out of service, send an email to Ward Watson, wwatson@timberlinefire.com, and he will put that on his list of things to address. And then, as with anything, only properly trained individuals should repair or refill extinguishers. Dealing with high pressure, dealing with a safety apparatus, there's very specific techniques and methods and equipment necessary in order to properly maintain these. So it's not something that we should be taking on by ourselves. Some obvious points, general guidelines when caring for extinguishers: never drop them or throw them. They're a high pressure device. The caps and the valve mechanisms can be damaged. If it's not damaged to the point where it's visible, it could be damaged to the point where it is not going to function when you use it and you hope that it functions. Carry it according to the size and weight. If it's something that you can't comfortably carry by yourself, have somebody else carry it or go to 2 people to carry it. Remove the pin only when it's ready to be used. Don't mess around with the pins. The pins should be safe. Store it securely, of course. If they're not in a proper bracket, they can be tipped over or knocked over, potentially damaging them. When we're done using them, lay them on the side, as this firefighter is doing, on a tarp. Don't store or stack items in front of it, even if it's wall mounted. And shake the dry chemical extinguisher upside down a couple of times monthly. So we want to make sure that that extinguishing agent inside the powder is free. If it's caked up, it may not operate adequately when we need it to. We may not get enough. We may not get as much extinguishing agent out of it when we need it. So after every use and periodically, use warm water and soap to remove dirt and grease. Avoid solvents that damage plastic parts. Some oils and greases and lubricants can attack the rubber of the hose or the plastic of the nozzle. Some extinguishers have plastic valve components. They're not typically an industrial type use, but home type use may have plastic valve and caps, and solvents can damage plastic. Can damage it to the point that it is dangerous to use or may not function when it's needed to. Steel wool or sandpaper can remove corrosion, and then only trained personnel should repair or refill. Now, we may talk at a future time about refilling a type A water can extinguisher. There's a very specific method and steps to do that. Annually, as we mentioned, and as Ward's been working through recently, includes a thorough inspection, potentially disassembly. Pressurized units must be hydrostatically tested. So what this is at appropriate time periods. At appropriate time periods, the cylinder itself has to be emptied, hooked up to a hydrostatic test unit, and then it is placed under a certain pressure to assure that the cylinder itself is still maybe some damages to the cylinder itself over the course of time, dings and dents that, while it doesn't look significant, it can potentially not pass the hydrostatic testing. This is similar to what's done for scuba tanks, tanks used for acetylene and oxygen for welding and cutting, as well as for our self-contained breathing apparatus air tanks. We've just recently had all of our SCBA tanks hydrostatically tested. So the same thing happens with fire extinguishers. It's not just something that you buy once, leave in the corner to get covered with dirt and hope it works 10, 12 or more years down the line. They have to be properly maintained. And then, as Johnny mentioned, the dry chem units need to be emptied and refilled every 6 years, on his very special hints and tips from Mr. Watson. So we've talked about the caution. So we'll go through the summary real quick. Portable extinguishers can be used to control or extinguish small incipient fires. Incipient fire is one that is just starting, and we'll learn the terms for the different stages of fire growth in our fire behavior class. So incipient is the early stage of the fire, or early growth. Fires go from incipient to growth stage, and it can happen very quickly. So an extinguisher can be very effective in the beginning or the early growth stages, and sometimes even a little bit further along. There are some tactics and techniques that can be used for a water can that can really stretch the effectiveness of the water can. You have to be familiar with the characteristics in order to select the appropriate extinguisher and use it properly. So that is the PowerPoint presentation for tonight. We have the learning objectives, which are things that we'll talk about down the line as we will have a portable fire extinguisher hands-on day, which will give all of you a chance to use a water can fire extinguisher, and we may hopefully have a number of dry chem and dry powder and maybe a carbon dioxide extinguisher or two that we'll be able to use for our practice hands-on days. So does anybody have questions that we can talk about or discussion points that you may want some more information on?
I just have one question. I know you kind of touched on it earlier, but just to clarify, what type of foam do we have, like on the engines or on the tenders? Are the brush trucks? Does it kind of vary, or do we have multiple types of foams? Or
I don't know if my speakers aren't working for some reason. I saw Steven had his microphone on. Chief Bondas has a mic on.
Yeah, so hold on, let me see if we can get in here real quick. There we go. That works. So if you guys have questions,
So can
go
you
ahead
guys still
and
hear me?
write them out.
Yes, okay, thanks. Steven had a question. What types of foams are on the engines? Right now, we probably don't have any foam on any engine except for 5.8. We have Class A type foams, and I can never remember the exact specific type of Class A foam. There are foam tanks on the engines and the tenders. We have a Class A foam on those. We've recently been switching out, we've tried to exhaust all of our old Class A foam because that exact type of Class A foam is the type that the airports and airport personnel had issues as cancer-causing agents. And it's I'm not going to be able to pronounce it right, a chlorinated type of agent in the foam. So we are in the process of determining a guideline and a procedure to replenish foam for the engines. Right now we have the safer type of Class A foam on a pallet in Station 7 in 5-gallon totes. And what we'll do is in the event that we have a fire or an incident where we need foam, we'll take the foam in the totes, and we have a system for the engines and the tenders that we can use foam directly from the totes with an induction system. So we can have the tote right at the rear of the engine, screw in the inductor tubing, shove it down into the tote, connect it to the pump panel, and it will automatically induce foam into the system. But those will be very specific types of situations where we'll be using that until we put our guidelines in place for that new type of foam. Good question. What other questions do we have? Or
So to
discussion
clarify a
points
little
or
bit,
things that people want to talk more about?
to clarify a little bit on foam, and John, I know you can't hear me, but hopefully you can see my face moving in the dark here. Let me turn the light on, hold on. So what we have right now is similar to an AFFF, and the thing that John's talking about that's sort of falling out of favor as a carcinogen is PFAS, which, you know, if you watch the news at all, I'm sure you've heard of it. Fort Carson had a big issue with it getting into the water supply. So the governor's order as of late 2019, if I remember right, was basically to stop the use of that foam. So we're moving from that system to, or that style of foam to I believe it's going to be a Class AB foam. that has no PFAS in it. So it'll work for the majority of what we do. The sort of shortcoming on that's going to be some hazmat issues, which could be a potential problem in the future. There's discussion on us maybe having a county cache of AFFF or a foam that's a little more suited for a flammable liquid fire or something like that. So there'll be a formal policy coming out in the next, I don't know, it was supposed to have come out early 2020, but with everything that's going on, obviously it kind of took a backseat. So expect to see some more stuff on that. The good part is when we do get that new foam system in place, we will be able to actually train with foam, which fighting fire with foam or CAFs system like our engines have is a pretty cool experience and something you definitely want to get some reps on before actually using it on an incident.